Anders from Anglo-American Oil. This came about initially through having to fit too many fuel pumps to my car, so I was wondering what on earth to do about this, what the problems were. And I heard about this storage fuel, and it came about through the conversations that we usually have. And now I'm pleased to say I made the acquaintance of Anders. I've got storage fuel in my Garage Queen 944, and it's never failed to start since, all the time that it's been laid up in the winter. So I thought, I know that there'll be quite a few others of you that are interested in this and the effects on maybe some of the not so old cars as well as fuels and oils have evolved. So that's enough from me. Anders, I'll leave you with our membership, and thank you very much for coming along for this. Thank you.
My name is Anders Hildebrand. As you can hear, I'm not entirely British. I was actually born in Sweden. This is me outside our headquarters in Poole in Horton Heath, where we have our company. My first car was actually a Porsche 356. I was very young then, so this is 1960. I was very much in making, because that's actually my mum. And I'm there. So you can say really from a very, very young age, I've been into my cars. Fast forwarding, I sort of went to school, of course, as you do, and got a racing bike when I got the opportunity to actually, this is how I got in contact with England. I always loved the Ford GT40s. And in Poole, there was a company called GT Developments. And I managed to convince them that I was the perfect importer into Scandinavia. And of course, to prove that it was a really, really good car, I thought, I'll start racing. And how hard could it be? So this is Brands Hatch, 1998. At the Winter Championship, and I managed to finish third in that championship. It was quite pleasing because I'd never driven a Porsche at race circuit, never been to Brands Hatch before. So that was good. Then 99, I jumped into the Renault Spider Championship. I raced with the likes of Andy Prio, another in Porsche circuit should be Mark Cole. He sort of won the Porsche Super Cup a couple of years later. He finished fourth. He finished fifth. I beat him. I finished fourth, which I was quite pleased with because I'd never been to the circuit. So that was good fun. And then they canned it. So we started this journey to try to sell oils. But anyway, we started in 99. We focused on high-performance oils. So these are basically milestones with the company. We introduced a non-ethanol garden machinery fuel made in Sweden called ASPEN. It's ready-mix 2-stroke or 4-stroke for lawn mowers. You can sit in machines for as long as you like and it still starts and reduce toxic emissions with 99%. But as with oil, it was super hard to get people to realize that why they should use it. So, just an expensive fuel, who knows, who needs that? Now with ethanol, destroying the fuel systems, 1.7 million litres last year. So, grown quite nicely. In 2019, we started to distribute drift tyres, mainly because our son competes in drifting. We also then started with BMC cotton air filters, which is a good Italian filter brand, something to do with Porsche as well, I'll tell you later. We started manufacturing the storage fuels, which along more or less the same idea as garden machinery fuel, but designed for bikes and cars to give you better throttle response, higher octane, easy start, makes engines run beautifully. And we started to sell avgas in 2020. We started to distribute car care products, because if everything goes to shit and we can't drive petrol cars or cars with ICE engines, and we have to have EV cars in the future, we can still polish them. So yeah. This is the continuity. Right, so we're based in Poole and Dorset. We have about 400 square meters of offices. behind this building we also have oil plant, we have a workshop, we have about 1,500 square meters of warehousing, especially built for storage of flammable liquid, which was not the easiest to get in, get through. And on the back we have blending tanks. They are one specifically for leaded fuels, one for unleaded fuels. All stainless steel 316. I think it's the only one in the UK with that sort of grade or quality. We also introduce, right now, we are also putting in another 120,000 litres of storage in bulk, just to try to drive costs down so we get raw materials in storage. We operate 3 Arctic trucks and 1 26-ton trucks that we take to race fuels. We built this in 2015 out of scratch, and up until 2015 we actually operated the business from home in our extended garage, and we rented space within the chemical factory up in Membury. So this was a big milestone for us to be able to afford to do that. We represent SUNOCO race fuels. SUNOCO is the largest producer of race fuels in the world, and we operate in Europe and Middle East through distributors. There's over 20 championships in the UK running our fuels, and several in Europe as well. We cover from 100 octane up to 120 octane, both unleaded, leaded, and of course now sustainable fuels as well. The storage fuels we put under Classic Fuel Solutions brand, which is the storage fuels. We've got unleaded and leaded. We've got motorcycle racing fuels under that brand. The driven racing oil is a brand that is not an oil company trying to make race oils to sexy up their offerings. It's actually a race team that had big issues with oils because they were modernized. In late 1990s, the Joe Gibbs Racing NASCAR team, which is one of the bigger teams, they started to see increased valve train wear. They didn't understand what on earth was happening. They were sort of questioning the guys that did the hardening of the camshafts, the material of the lifters, the push rods. Everything was the same. And they were seeing more and more issues with wear. And they then finally thought, could it be something with the oil? But we're using the same oil. And they were actually using the 76 high performance NASCAR approved oil. But they went then to a company called Lubrisol. There's basically 2 big companies in the world that makes additives for the oil industry. It's ASPEN and Lubrisol. So the big oil companies, the big brands, they produce their own base oil and then they buy additive packages from these the 2 additive suppliers, and they approve them for different API or CR ratings to go with the manufacturer's development of the engines. So they talked to the R&D guy. His name was Michael Mucha. He was the technical director, also a NASCAR fan, and he said, yeah, of course you've got issues, you're using that oil. You always use that oil. Yeah, but it's been modernized. Well, isn't that better then? Gone from a sort of higher API rating and said, no. For a modern car, yes. For lower emissions, yes. But for protection of engines, the amount of anti-wear additives has been reduced and the level of detergents have gone up. So they then thought, okay, let's see if we can fix this. So he blended an oil for them, and they went from a 2050 in the race engines to 520. And they also got a special running-in oil when the engine was new to make sure the camshaft and everything was hardened. And basically all the issues just went away. They got more power, lower oil temperatures, and no mechanical issues. Of course, this spread within the NASCAR paddock. So what happened was that the volumes went up, and they spent lots of money on the development of the oil. And they thought, well, race on Sunday, sell on Monday, we sell last year's formulations to the other guys that want to buy it. So in 2004, they actually launched the oil. And I met Lake Speed Jr. At the PRI show. We hit it off, and he gave me this oil to sell, one oil. And the range has now grown to massive, because a 520 is very difficult to sell for just racing when you want to sell to the classic market, the street performance market, Porsche owners, etc. So it was tough to start with, but I was happy to sacrifice the volume I had with 76 oils, because I knew that they were just going to follow modern formulations and lose the protection we needed in the classic vehicles. So today there's race oils, street performance oils, classic car oils. They even have an oil specifically to stop low speed pre-ignition, which happens if you have too much calcium in the oil, which is basically detergents, because you can get the oil when you have a direct injection engine instead of 100. You got much shorter time from when you inject the fuel to allow it to atomize before you start to burn it. So you have droplets of fuel integrating with the oil, creating a very low octane solution in the ring glands, and you can shoot it off like that, just without driving normally, poof, and it just goes. So it's something that they recognize, and you need to specially formulate the oils for that. And of course, your gearbox oils, transmission oils, and additives. Tires, it's not just drifting, it's also track-day tires. These are low cost, because in drifting you're happy if a tire lasts for more than
5 minutes.
Well, 2 minutes. It's a lot of power, lots of drifting, of course. We managed to get, because Axel with his contacts in drifting, and he also works in the company, we got to get the official tire for British Drift Championship and the UK Pro Drift Championship. Avgas, we sell that in drums, because that's what we specialize in, fuels and oils in packages. We don't do bulk. So we do the 91 octane and the 100 octane. So LL stands for low lead. It's shed loads of lead in it. But it stands for low lead. So in 200 drums. The SONAX car care brand is the biggest car care brand in Europe. They've been going for over 75 years. They have a huge range and good products if you see them. We are building, they are not available. You can buy them from us, of course, directly, but we are building up retailers now. It sets SONAX apart from any other car care brand. They've got 33 full-time chemists testing, developing. Most of the brands you buy are third-party, private label, made in China. BMC air filters, Italian-made. Cotton filter technology. It's better filtration, less resistance, and they sound much better. BMC are, this is another selling point. You can actually clean them, so you don't have to throw them away. Just clean them and put them back again. And 90% of their front grid are actually using BMC. They're not sponsored, they buy them. Apart from Ferrari, because they fell out because they didn't want to give the filters to Ferrari. We have filters for nearly every car, including Porsches, and for the top models, OMP is, or Porsche is for GT3, GT2s. That's what they use.
Do you have bike filters as well?
They do bike filters as well, but we don't look after that market yet. There's someone else doing that, so we just focus on the car side. But it doesn't matter which car you have, there's a BMC filter for it. So we stock over 400 different filters now. Right, so ASPEN, we mentioned that, specialist 2- and 4-stroke alkylate fuels. And alkylate this is not just a normal petrol with some additives. It's actually made from butane gas and other gases that comes from the top of the distillation tower, which is then taken through a alkylation process, and now it comes a liquid, which is, there's no double bonded hydrocarbons, only single bonded hydrocarbons, burns extremely cleanly. Virtually no carbon build-up at all. Because if you have a carbon bond, if it's a double bonded and it breaks, it has to find 2 oxygen. If it's a single bond, it breaks, each carbon has to find 1 oxygen, which is much easier. So we use a lot of alkylate in the race fuels as a base fuel. It's like the foundation of the fuel. And then we add things to increase power, increase octane, etc. So I don't know, many of you got sort of gardens with lawnmowers and trimmers and...
No, we have people to come in for that sort of thing.
Good. Yeah. So we have a network of 600 dealers now. So we sold 1.7 million litres last year, and it's growing very, very quickly. People may say it's expensive. It costs £5 a litre, which is expensive compared to pump fuel, but also you have to put in relation how much do I actually use. Yes, reduced toxic emission, we have 99%, we have it in different sizes. The only thing is that don't get the idea of putting this in your motorcycles because it's storage stable. You will get issues with your seals. Because rubber seals using normal petrol expand. That's what aromatics do. They replace natural rubber softeners in all the pipes and the seals, and if you then put ASPEN in, they may shrink and you may get leakages. So they say we don't recommend that at all, and that's why we have the storage fuel instead, which contains aromatics. But yeah, I put this picture here because what typically happens springtime when you try to start your lawnmower, if you have normal petrol in it, is that your vocabulary gets a bit like that. Right, so we're not going to talk about race fuels, but I just wanted to point out that there is the difference between race fuels and pump fuels, that pump fuels are made to minimum standards, to be as cheap as possible, to maximize the profit from the petrol stations for the oil companies. Obviously, they try to make us believe that Shell is better than BP and Esso is better than Shell and all that. But it's all about making it meeting the standards. And all fuels in the south comes more or less from Foley refinery, the Esso refinery, regardless of what it says on the fuel station. They might have a different additive package in the fuels, but the base fuels are the same. Not so much the supermarket fuels, which comes from another supplier, which typically buys fuels that haven't met the standards, and then they jazz it up, they put in different chemicals in them. So I never go to the supermarket to fill up. So focusing on cost, consistency, not an issue at all, especially now with modern ECUs. The engines can adjust quite happily to different quality. Whereas race fuels, we are designed to give more power. We typically build the fuels to maximum tolerances in terms of octane, in terms of additive we can put in to give us more power. So we're restricted of making them good instead of making them bad. They burn much cleaner because we don't have the general refinery stream from refining. We start with alkylate, we then add aromatics, we add oxygenates, olefins, whatever you like the fuel to have. Depends on applications. If it's a high revving engine or turbo engines, we build them differently. And also to be extremely consistent. When we blend fuels and design fuels, we make sure that we should be able to replicate it time after time after time. So that if you tune to a race fuel, you shouldn't have to retune it because it's a different batch. It needs to be the same. And cost is not such a big issue. Of course, there's a limit how much it could cost, but of course performance and consistency is very, very important, because today a modern race engine, or even a classic race engine, or a classic Porsche, we're talking mega money today. We're talking sort of not £5,000, you're talking £50,000 for a good Porsche engine in a classic race car. Right, now, with the E5 and E10, people are like, why on earth do we have these? Why do we have ethanol in fuel? Well, it started quite a long time ago. And it basically started with, in America, when they wanted to get rid of tetraethyl lead. So, because tetraethyl lead is great to boost the octane of a fuel, really, really good. And of course, with the higher compression engines, we need that octane to avoid detonation and also to make them efficient. MTBE, or methyl tetrabutyl ether, is an oxygen carrier, very clean burning and very high octane. Has a blending value of about 114 octane, so less than lead, but still high enough. What they then found was that by adding oxygen into the fuel, suddenly the emissions came down. And there was a huge issue in California, especially with smog. So they found when they added this that the air quality improved. So what they didn't realize then, that MTBE doesn't break down. And with old fuel tanks in the ground leaking, they started to get groundwater contamination. So then from being really, really good, they, oh shit, we have an issue here. So in 2006, they stopped that in America. But of course, they couldn't just take away the oxygen, because then they get more emissions again. So then the farmer said, we have ethanol! And that's how ethanol came into the fuels. Much earlier in America than over here. So that's a formulation for ethanol, which looks like a nice little dog if you put it together. And if you add water to ethanol, we all get very, very happy, because that is basically what we are drinking: beer, wine, any drinks. So that is, oops, happy times. But it could be an issue with our cars if we don't have the right equipment. This is a friend of mine who came over to Goodwood Revival. We spent so much time actually trying to flush out all the debris that has been loosened by the ethanol, because he hadn't driven it, he just bought it, been in storage, decided it's a Mercedes, I can drive to England, no problem at all, filled it up with E10 when he came to England and conked out. There was so much crap in the fuel system, you wouldn't believe it. We finally got it sorted. So that is, of course, an issue with ethanol. So the pros, we add oxygen and octane, clean emissions, more performance for engines that are designed for it. It can cause issues, of course. And it's deemed to be carbon neutral. So when we burn ethanol, create carbon dioxide, but then the plants grow and consume it. So that's what everyone likes now, the circular environment. It's very hygroscopic. As you can see, put a bit of ethanol and put any sort of water or Coca-Cola into it, and then it mixes perfectly. It loves moisture, which is a bit of an issue because it forms a type of bacteria called acetobacter, and then they excrete acid, which then sort of cleans off the natural oxidation layer on all the metals, and we get direct corrosion on aluminium, copper, and brass, for example. It also will affect rubbers, dries it out. Another thing is that because the ethanol molecule is smaller than the petrol molecule, it can easier pass through the piston rings, ends up in the engine oil. If the engine oil is not properly engineered, with this, like the driven oils, with the storage additive, you can get internal engine corrosion. So here's some examples. This nice little rubber hose. I don't know if you can see properly, but yeah, it's all that white there. There's actually corrosion. That ethanol has eaten away of the metal. We don't notice that in our classic vehicles. We drive them, we're happy. It doesn't happen, it doesn't go stop like that just because you put an E10 in, but it slowly eats away, and then it can start blocking jets, which is very, very annoying when they start to run badly. So as a company, we can offer two solutions to stop this. One practical during the summer is an additive that is designed to shield the system from ethanol. One little bottle treats 95 liters. And
how many litres, sorry?
95 liters. So it goes a long way. They say it prolongs the engine life a little bit. Yes, it does. But of course, it's not a pure fuel. You don't make the fuel you have pure because of it. It's help during the season when you turn around the fuel quickly in your car. So it still absorbs moisture and can cause issues for longer layoffs. This is the best solution, of course, a storage fuel, which we call it storage because you can leave it in the car for long, or motorcycle or boat for a very, very long period of time, and it still starts. So 2 years, starts on the button. And it's, of course, guaranteed ethanol-free because we make it. It's basically alkylate, got some aromatics, we got some isobutane to make sure we get the right vapor pressure, to help with the starting of it. We say it's up to 3 years because it's only 3 years old, the product. So, you know, it's definitely good that. It doesn't leave any varnish, does not corrode the system, and it burns super cleanly. Really, really clean. You don't get that hesitation and, well, Paul knows. You used it. Yeah. So it works. And it's high in octane, it's 99 octane, but the motor octane number, which is a number you've never seen on UK forecourt pumps, is 92. And the Supran lead sits at around 88. And the motor octane number is actually the measurement of octane at full throttle. So that's a more important. And this is something that is could be good trivia. If you go to America and you go to fill up at the fuel station, you say, octane is not very high here. Poor sods, having to reduce this low octane fuel, 90 octane, 88 octane. Yeah. Oh, 94, is that the best they can do? Yeah. They actually take the average between research octane number and MOL. So our premium,
take it all back now.
our 95 octane is American 90. Our super is American 92, 93. And there's quite a few race engines that's gone bang coming from America when they talk to the UK customers, when the UK customers then say, hey, what fuel should I use? Well, you need at least 95 octane. Not a problem. We got 98 octane at the pump. Oh, fantastic. Use that. Put that in. Happy days. Bang. And no one understands why. Very important. We found that the distillation curve is quite similar to older type of fuels. So that makes the engines run really, really smoothly. And the issue we had first is that if you lay off your car or your bike, you don't really want to buy loads of fuel. Maybe 10 liters is enough. It's enough to flush the system and keep it in the system. But of course, it's quite expensive because it's flammable to send it from us if you're up in north of England. So we came up with the idea to actually sell it through our garden machinery dealers. So when they order a pallet of ASPEN, we just put a couple of cans of storage fuel on, so it's no transport cost. And that's been a real success. You don't have to do that, you can come to us. So if you want to use it, sort of lay off your vehicles. But of course, there's a downside, it's a higher cost. But it's much cheaper than what I experienced when I sold an old Corvette and I took a Kawasaki 1100 Zephyr in part exchange. Looked quite cool. I thought, yeah, I can use that. Eva doesn't need to know. And sort of hid it in the garage at work and run a bit rough. I thought, just old petrol. I just throw that out and put some good petrol in. It'll be really good. No. I changed the spark plugs, the leads, we looked at the carburetor, they looked all clean and nice. Spent 2-3 days, a couple of £100, still run like so bad you wouldn't believe it. So I thought, there must be something. Sent it away to Kawasaki, and £500 later, it ran really, really smooth because they knew which jet was blocked. So if that customer I got it from, or the guy who bought my Corvette, had put that in and spent £48, whatever it is, including VAT, that would have been the difference. So it cost me £700. And that story, I hear that all the time. People should have used that instead. So, and it's a growing issue. Because we don't see that gradual build-up and gradual destruction of the fuel system. So we got 2 versions for those really high compression engines, or those that need leaded fuels. We got that as well. And lead, I said, lead push it up the octane quite high. So we're talking really high octane fuel here. The fuel is actually this fuel here is actually so good. So I got one British Superbike team that says it's better than the race fuel they get from the control fuel supplier. So they buy the storage fuel from us and do all the testing on it and all the racing outside the championship on that. So, which surprised me a bit, but they're happy. Right. Sustainable fuels. This is a big topic everywhere. Is this a saver for not having to only have EV cars around us? It could be. And we have worked quite closely with organizing bodies to develop sustainable fuels. And the first one we sort of worked with was Goodwood. But I thought I'd just quickly go through here what the difference between biofuels and sustainable fuels are, because a biofuel is not necessarily a sustainable fuel, or sustainable fuel is not necessarily a biofuel. But very common, a sustainable fuel is a biofuel today. So biofuels, they call them Generation 1 fuels. They're made from plant, could be made from forestry, or that consume CO2 when they grow, so that we get that circular environment. They are, as you know, represented by ethanol in pump fuels, which is gradually increasing. We can see that increasing because this is, as a fuel producer, there's a penalty if we don't have, I think it's 9.7% or 9.8% of the fuel being a bio component today. And the penalty is that we have to pay 50 pence per litre of missing biocomponent. And that's the same for diesel and for petrol. So they're forcing that. They also now, you need to have a sustainable component in the fuel. If you don't have that, you have to pay a penalty. So for us, with the garden machinery fuel or the storage fuel, we have to pay penalty because we don't have the biocomponents in the fuel. Which is a bit frustrating when you have a fuel that reduces toxic emissions and it's not used on normal roads either. The issue is, of course, that we burn what we can eat. And it's not really scalable because if they're all going to be biocomponents, fuel made from from ethanol made, the sort of generation 1, we're going to run out of land. Or we don't have anything to eat. So in that respect, EV cars might be a good idea. But so that's not really sustainable in the long run. So generation 2, yeah. So generation 2 fuels are made from waste. So sustainable aviation fuels, you heard of that, they're talking about Boeing and that's where you take, so from the food production or from restaurants, things that are thrown away, you take that and you ferment that and typically make ethanol from it. That's a generation 2 ethanol. And that can then be used as a fuel in itself. Or you can take that ethanol and put it through a processing plant. There's one now in Europe, it's in Poland, called EcoBenz. And that's where we buy our hydrocarbons from. So they process the ethanol into hydrocarbons, which are very similar to petrol. Well, similar to petrol as it was 70 years ago, because the octane is like 91 RON, so very, very low. So making race fuels is actually quite tricky when we use that. And then the next step then, when we get really, really advanced, is that when we make sustainable fuels from carbon capture. There's lots of projects going on. You probably heard of the Porsche project in Haruni, where they capture carbon and using wind, because there's lots of wind down there in Chile. Because that's the key when you make a sustainable fuel, the energy needs to be sustainable as well. But that is scalable because there's plenty of carbon in the atmosphere, got lots of water, and so we can make fuel from that. We are shareholders in a company called Zero Petroleum. It's run by Paddy Lowe. Probably haven't heard of that company, but it's very much upstart now in synthesizing fuel from hydrogen and carbon dioxide. And right now, after lots and lots of investment, we are producing about 3 to 4 liters a day. So that's sort of, but
from little acorns.
yeah, exactly. The government, they focus everything on EVs. They haven't until last year put any money into development of sustainable fuels, or e-fuels, as when you do carbon capture, that's called e-fuels. So grants are coming now. So, but this little plant, which is in Bicester, that produces 3-4 liters a day, can be scalable and just add it on and build on. So the next step is to build a plant that makes 140,000 liters a year, which would be great for us, because that's sort of, we can buy everything they can produce and make race fuel from it. Obviously, the cost of these are stupid money, really stupid money. But the fuel is very similar to the fuel made from ethanol generation to ethanol. It's just different ways of making hydrocarbons. And the really exciting thing is that with this process, is they are now discovered they can make new molecules that doesn't exist. So they've gone from, well, we need to replicate petrol to put in our combustion engines, to actually, how can we make better molecules with more energy, so we get more power and more miles per gallon. So it's really, really exciting. And it's very, very early days, but it is happening. So there's good hope for the future. But it's not going to happen tomorrow. It's going to take a long time, and a very long time until we see it coming into pump fuels. But if the money is there, if the investment is there, it can happen much, much faster. So if any of you sits on a couple of trillions, talk to me. I know where to put them. Right, so at Goodwood Revival, and this is sort of nicely linked to Porsches. Good Revival wanted to have Ford Water Trophy run on sustainable fuels. They had a big sponsor to come in and said, yeah, we're going to do this, another fuel company. 3 weeks before the race, Good Revival said, we got a bit of issue. We told everyone we're going to run sustainable fuels. The guys who said they can do it now says they can't do it. And we've been working with Goodwood and behind the scenes. We built a petrol station there. So since early 2000, we've been fueling all the cars from America, wherever they come from, we can make fuels. Most exciting fuel was when we made the fuel for that Auto Union, the 16-cylinder engine. That was some cocktail to put together. I'll tell you that. And we got some left over, which I don't know what to do with. But anyways, so they rang us, we have a big problem. We need you to help us out of this little hole here. We're going to run the race. We don't have a supplier. Can you fix it? I knew how to do it. I knew the components. I didn't have the components. We haven't blended the fuel yet. And we hadn't definitely not tested it. But we did it. We got all the components. We used our experience, how to design fuels. We blended the fuel, sent it to engine dynos, and said, great, we got more power. And so off we went, and the race was a success. So Goodwood was so happy, and the Duke was super happy, so they then decided to run 2 races at the Goodwood members meeting, the Gordon Spice Trophy and the Ken Miles Cup, the Ford Mustang race, and the Group A, sort of late 70s, early 80s cars on sustainable fuels. And I told them, we can't run on that fuel, we run in the Porsches, because these engines are completely different. So over the winter we had to then develop 3 more fuels to satisfy the need of the engines, because I knew they wouldn't work if the guys had to re-engineer the engines to suit the fuel. So, but we did that. We worked with engine builders, and that worked absolutely fine. So the Duke was then even more excited, said every car is going to run on sustainable fuels at the Good Revival meeting 2024. I knew he had planned to do it 2025. So I said, okay, so now we are going even wider. We're now going back to sort of early 1910, 1920 cars. And so, but a fuel is a fuel, and it worked absolutely fine. We introduced another fuel, plus the really difficult one was to find a sustainable methanol. And in the good old days, methanol was made from the forest industry. Now methanol is all made industrially. So, but thanks to our Swedish roots, we knew people within the Swedish forestry industry, managed to find someone that actually manufactured methanol and was willing to sell such a small volume to us. We only needed 3,000 litres, and not, for what they were using it for, their application, they were sort of like tanker loads. And that arrived on Wednesday morning, delayed of course, Wednesday morning when we were packing the trucks to go to Goodwood. And we got in 3 IBCs, we hadn't put it in the cans yet. So that was slightly nerve-wracking, but it worked. Right. So now, after all that background and a little brush of fuels, I thought I would talk a bit about oils. Because for many, oil is oil. There's no difference. It's just different packaging, different branding, and some are cheap, some are expensive. I don't see a difference. I just put it in. The engine doesn't know, but it's a big difference. And so we work with driven racing oil, and we've done that now for 21 years, and we have been very close to them in terms of working with them what the market actually needs. It's not just racing, because big market is the classic cars, the classic Porsches from the 90s, 2000, early 2010, suffer, believe it or not, using modern oils because of different reasons. So just basic what oils do. Of course, we reduce friction in the engine, that's natural, but we also cool the engine. It transfers the heat out of the engine like coolant. So it's very, very important. And with oils, you've got lots of different types of situation in the engine, where just a normal base oil will do absolutely fine. That's when you have sort of lightly load, the oil sits there, no issues whatsoever. So these here, this of course magnified metal. When you look at the piston rings and the cylinder walls, they don't really look like that, but that's sort of if you magnify it. So you have full film lubrication, you have mixed film where you have a little bit of touching, and then you have heavily loaded, like lifters, the rocker arms. And this, the boundary lubrication, that's where you need a good additive package. And one thing that, from a mechanical point of view in engines, every year the engines get less and less stressed in terms of internal engine friction. The engineering, the precision is much, much tighter. We can run thinner oils. There's less load because we want to, if you can reduce the load, we reduce friction, we get better miles per gallon, we get more power. So that's where everyone is focusing on. So every year that is improving. So the oils change with the environment. Now, sacrificial coating, what do I mean with that? Well, in heavily loaded application, like performance engines, where the stresses are higher, so the boundary lubrication happens more often than in a lightly tuned engine. So what you need then, it's not just the oil, it's anti-wear additives. And one of the most efficient one is called ZDTP. It's a zinc additive that basically manifests itself on the metal. It's a polar molecule, so it wants to stick to the metal and form that layer. It's like if you paint a car, it is sort of the filler, basically, before you put the paint on. So you need that, so the metals, well, a good way of explaining it, that is the metal magnified. There's another metal. So if we don't have any anti-wear additives, so the oil has to do all the job. Light touching, not such a problem. Heavily loaded, the fingers goes into each other, and you put quite a lot of pressure on the tips, they will break. They break off, and what was now my finger is now a little valley. And that breaks off, so a new tip comes off, and very, very quickly you can get increased metal wear. So what the ZDTP does, being a polar molecule, it goes in between the fingers, so now my fingers are like that. It's more or less filled in between. And now they can grind quite happily against each other without wearing. But the sacrificial layer will wear, so you need to continue having that oil that adds those polar molecules to make sure you have that gliding surfaces not touching each other. And then you have a happy engine. So, cams, lifters, push rod, wrist pins, distributor gears, bearings, etc., all are affected with an oil that hasn't got enough anti-wear protection. Now, the oils are, if you think back to when I said that the Joe Gibbs racing team have issues because they had changed the additive formulation. So they actually reduced anti-wear additives and they increased the detergents. Because from an environmental point of view, if we can keep the oil in the engine for 18,000 miles instead of 12,000 miles, it's good, if it doesn't affect the engine badly. So that means more detergents. And the downside with the detergents, apart from keeping the engine clean, which is good, so the downside is that they're also polar molecules. So they also want to stick to the metal surface. So whereas the additives want to be there to protect the surface, the detergents want to push it away, wash it away. And so with the modern oil, with more and more detergents, less and less anti-wear additives, more wear, if the engine isn't designed for it. And like the Joe Gibbs Racing NASCAR team, if you have a Porsche from, I said, the 90s or earlier, or up to early 2010s, and you go and buy the modern Mobil 1 oil, I can guarantee you that is not the oil the engine was designed for. Because now we are talking oils for longer service intervals, hasn't got the right additive package to protect the engine. And that's why bore scoring, for example, quite popular in Porsches.
Prevalent is the word.
Prevalent, yes, thank you. Excuse my Swinglish there. This oil here, the DT40 and the DT50, DT stands for Deutsche Touring. It's actually Porsche Club of America, who also very active in racing, using Joe Gibbs oils, said, well, we have an issue. Which race oil can we use to mitigate this? I said, well, you can't use race oil in road cars because we haven't got enough detergent. It will sludge up quite quickly. Well, you know how to make oils. Make one then. So I started to look into it and realized that's actually a big market here because there is an issue. So they developed that oil. And I'll show you a bit later, sort of, I can't remember where it is. A bit later, what the difference is. But yeah, so that oil will, if you have bore scoring, will not fix it. But if you fix the engine, it will never happen again.
Anders, can I just ask, what's the level of ZEDP that this oil has? And could you use that oil in, I mean, you said up to 2010, but what about after 2010? Would you use it?
Yeah, no problems at all. It hasn't got enough that it's too much to affect the lambda sensors or catalytic converters. So it's absolutely fine for that.
At what level? 1200?
It's about 1200.
Okay.
1200. It's a, some think that, oh, we have 2,500, that is good. No, it's not good. It's a sweet spot for sort of high performance applications. Yeah. If you have an oil for running in, then you want more because you want the oil to be acidic, because that's the result if you have too much anti-wear additive, so too much ZEDP, because you want to soften the piston rings. So there's no benefit in going too high when the engine is run in.
Okay.
So
just taking off your commercial hat.
Yeah.
Okay. The oil that Porsche recommends in the turbos is whatever it is. It's the Mobil 1.
Yeah.
0W40.
0W40.
Yeah.
Could you move to?
Yeah.
And is that better than the 040 Mobil 1? Because it's a DDP.
Yeah, because it doesn't meet the modern standards. The standards are environmental standards.
Yeah.
They work with the environment agencies and also with the manufacturers to reduce all these emissions. So we have a little bit more emissions, but we protect the engines.
Okay, so I take my car to Porsche Bournemouth to get serviced, and inside it I give them the oil. I shouldn't give them that.
They probably have a fit.
Would.
Yeah, but
what about the warranty?
It will fail the warranty because it's not an
warranty.
approved oil.
Yeah, I would sort of, within warranty, I would stick to what they say, but out of warranty, that's a better option.
Yeah.
Either that or you put that into a Mobil 1 can and then
That also doesn't work, by the way, because they won't take it if it's in an unsealed can.
Well, we could fix it. No, we
But we know a man that can, yeah? Excellent.
Right, okay, so very quickly, a bit breaking down our viscosity. The higher the viscosity, the thicker the oil is, the slower it flows. You probably know that, for example, SAE 10W40 or 0W40. The 40 is an industry standard at 100 degrees C. It is not that it is 14.0 centistokes. It's between 12.5 and 16.5. Can be wrong half point here and there, but that's where it sits. You can have a thin 40 weight oil, you can have a thick 40 weight oil. The 0W is a measurement of the shear resistance at between -12 and -25 degrees, depends on the viscosity of the oil. And W stands for winter, so minus. So a 0W40, a 5W40, a 10W40, a 15W40 at 100 degrees C, they are within the same standard. But the difference is, of course, that a 0W40 is much thinner when it's cold. So you flow better before it warms up. But when it's warm up, they have the same viscosity. The reason why some oils are thinning down with use is due to the multigrade additives to make it into multigrade oil and the viscosity index of the oil. The higher the viscosity index, the slower the oil thins down, the base oil. So if you have two base oils, for example, they're both 5Ws. One has a high viscosity index, like the driven oil, which has got a viscosity index of about 200, which is a MPAO, or if you use the one that Mobil use, which is a PAO, has got a viscosity index of about 150. So you've got the same base oil, the same thickness, you want to meet the same thickness at 100 degrees C. The one with the high viscosity index that naturally thins down at a slower rate doesn't need as many multigrade additives as the one with the lower viscosity index. And that's important because it's the multigrade additives or viscosity modifiers or VA improvers, different names for the same thing. It's basically liquid polymers, liquid plastic. If we heat oil, it goes thin, we all know that. If we heat plastic, if you all do alpine skiing and springtime, the ski boots gets much looser when you get warm. And so these liquid polymers, they expand with increasing heat and basically beef up the oil. So it slows down slower. But they wear through shear, they wear through basically being crushed, and through use. You all remember STP? Fix the oil in the, yeah. That was basically liquid polymers. Yeah. So the oil was starting to go thin, put that in, poof, came up again. Great success.
Porridge was also a good additive. Porridge.
Oh, I never tried that.
As good as STP.
Oh, God.
And sawdust, I believe, was quite good.
Yeah, that's gearbox oils. Right, so we talked about viscosity index there. We talked about viscosity modifiers. The additive package. So we talked about anti-wear and extreme pressure additives, moly and zinc. Friction reduction, also moly and zinc. Detergents, typically calcium. There are some other there, but calcium is the most popular one. And that's also the one that causes slow-speed pre-ignition in direct injection engines. So you have to be careful if you get if you have a direct injection engine and you put a long life oil in the engine, you can suffer detonation around the piston rings. And I said calcium competes against the zinc and the moly in terms of protection of the engine. You have different type of base oil. Basically 5 groups. Group 1, mineral. Group 2 is a hydrotreated mineral, so better quality, burns a bit cleaner in the combustion chamber, has a bit higher viscosity index. Group 3 is actually also starts from a mineral oil, but it is further refined, so it classed as synthetic oils in certain countries. But the pure synthetic oils, like esters and polyalpha olefin oils, that's group 4. And if you go to Germany and buy a Castrol or a Shell fully synthetic oil, it's a group 4. If you go to England, it's a group 3. It's cheaper and has nearly the same properties, but not as pure as a group 4. As I said, group 3 is mineral oils, but they are classed as synthetic oils in some countries. But there was a court case in Germany where Mobil 1 sued Castrol because they're using group 3 and call them synthetic. So that's why Germany is a bit special. And then you have group 5 is basically anything, refined oils, bio-oils, anything basically. Right, we talked about viscosity. So it's basically measured quite simply. It's a glass tube. The longer it takes for the oil to go through the tube between 2 orifices, the thicker the oil is. A lot of people, when they go racing, they say, oh, I need to have a race oil, I need to have a 1060 oil.
I know plenty that use 20W for this.
Yeah. And if you have not a very good oil, you might have to beef it up. But as with coolant, the thicker oil you have, the hotter it will run, and then it will thin down more. So it's always a balance what thickness of the oil you should have. Always have as thin oil as you can, because that increases the flow, and the flow is important. We talked about all this. Operating viscosity, that's quite an important factor actually. People may use one oil and they start to suffer oil pressure issues, so they then want to have a thicker oil in the engine, and which might fix that issue. But what people must also understand is that if you're running very, very hot day and you have an oil temperature of 110 degrees, compared to a cold day when the oil temperature is, let's say, 85 degrees, if you had an issue with when you run at 110 degrees and you think, I need to have a 2050 oil in my engine, so therefore I need to have that viscosity fix my issue, I need to have a 2050 all the time. But actually at 85 degrees C and a 1030 is the same thickness as a 2050 at 110 degrees. So that's what I mean with operating viscosity. And oils thin down quite dramatically. A 1030 typically go from centistokes at 40 degrees C to 10 centistokes at 100 degrees C. So much, much thinner.
There must be a point where all those graphs cross each other, I guess.
Well, they sort of tend to
Or they
merge at around 150 degrees C.
Okay.
Where they're all very, very small difference. We talked about today oils, whereas yesterday oils. So I don't think we need to talk more about that, but it's sort of driven by the environmental agencies to reduce emissions, and sometimes engines suffer when they get a bit old because they have a very thin oil to start with, to go through the emission. I know, I don't know if you saw that, so you can go back. The limit with the SN standard now to 800 parts per million of zinc, ZEDP, which is fine for new engines, but for the older enthusiastic vehicles it's not enough, especially if there's a high detergent level in the oil. And there's a new standard come out in March, which is the SQ standard 25. So here, I don't know if you can see here, but there's sort of difference in sort of how the different, like a race oil in terms of detergents and the anti-wear additives. So, but of course, a normal engine to race engine is a big difference in how they operate. We talked about this before, and basically I'm going to show you some graphs now to liven up. You know, I promise you, I haven't got many left now, so we're getting there. So, if you, so the whole thing with multigrade oils is to make sure we have oil flow when the engines are cold. In Sweden, it gets very, very cold. It's so much easier here in England. So, if you manage to read it, there's a test called KRL. It's a 24-hour test where they basically churn the oil. It's an accelerated wear test to see what the viscosity is of the oil before and after. So if we compare Mobile 1 to the driven DT40, so this one is designed to meet regulations. This one is designed to be what is best for the engine. So the 100 degrees Celsius center stove, Mobile 1, 13.88, slightly thicker than the driven, 13.03. After 24 hours, it's dropped its viscosity to 8.11, which is a 20 weight oil, whereas the driven is 11.4. So it's just under 40. So it is quite a big difference. The driven has lost 12% of its viscosity, whereas the Mobile 1 has lost 40. This is not because Mobile 1 is a bad oil. It's actually quite good. Most oils lose more than that. So, but with driven, because of the different base oil being very, very high in viscosity index and very few anti-wear additives, and as you remember I said, it's the anti-wear additives that break during stress and they really stress the oil. You can see the difference there. So the driven hardly loses any viscosity at all. Another interesting thing that I personally experienced with going from Mobile 1 to the driven DT40, oil temperature is at 103 degrees. And let's change the oil, bang, 96. It dropped 7 degrees by just changing the oil. So the oil is not just extremely viscosity stable, it dissipates heat extremely well. So that was quite amazing. I thought, is it me? But I was sort of, and it was actually warmer when it was dropped. And when I went faster motorways, it didn't, when I was in Germany with the Mobile 1, the faster I drove, the more the oil temperature actually started to go up. Whereas with that oil, it started to come down because of better cooling. So that was quite impressive. Another friend of mine who's actually the most winningest British GT driver, he's now down Dubai racing Porsche GT3. He loves driving, he's got lots of BMWs, got a BMW M3, and BMW says use Castrol 1060 RS, which of course he was doing. He's mechanically minded, he's trained as a mechanic, and we were on a flight to Daytona. We was chatting about oils and his cars, and I said, well, why do you use such a thick oil? Well, BMW says it, and he explained to me that when he was doing a track day, after 20 minutes, the oil temperature was 120 degrees, and he had to stop to let everything cool down, and then he could go out again. I said, well, I think you should use a thinner oil. So I convinced him to try that oil, and I had to guarantee him that I would pay for the engine if everything went wrong, because they are quite prone to actually wearing the big ends, the BMW M3 engines. So they changed the oil, went to the track day, rang me after they said, "This is amazing. The oil temperature does not go over 105 degrees. I don't have to stop. This is great." And since then, he's been a big fan. So any car he has, he puts it in. He recently bought the Porsche 996 Turbo, changed it from the oil it had in it, put the DT40 in, oil PSI, half a bar. I think it's a 0 to 5. I don't know what it's a bar or kilos, whatever it is, half a point higher throughout, warm or cold. So he said, super happy with the oil. And that is all about the engineering of the oil.
Is there not a factor of just the fact that you put fresh oil in rather than temperature anyway, or is that?
No, for me, when I drove to Sweden, with that, just had the Mobile 1 put in, and Phil Keane, the race driver, he changed his oil after each track day. So he compared fresh oil to fresh oil. Yeah. So here's some other oils. The Porsche 1060, same test, from 68 to a 38, massive difference. Castrol, the same. This is Porsche Classic 2050 compared to the DT50. So big difference in sort of how much they lose. Right, so that's me. That's my latest baby. Well, thank you very much, everyone.
Yeah, thank you, Anders.
Thank you very much for the evening. I think you all agree it's been very informative, lots of new information. I have a feeling you will have a few more customers as well with the storage stuff. But thanks for giving us a great evening. Thank you very much.
Thank you.